Hello class, this is a video tutorial on direction fields or slope fields part 1. In this video, we'll be looking at an introduction to direction or slope fields. Previously in calculus, we were tasked to sketch the derivative given the function. So here are 3 examples of something we may be tasked to do. So here we have a straight line, so y equals mx plus c. And we can see that its derivative would be just the gradient of this line. Since we don't know what the gradient is, its derivative we know is just a horizontal line, but we don't know where it is. So for example, this could be y equals 2, because the derivative of this black line could be 2. But if we were given the exact function, we could find that its derivative is 1. Therefore, we could see that it would actually pass through the y-intercepts as well, like this. Likewise with this, we don't know what the function is. For all we know, it could be y equals 3x squared. Therefore, its derivative, y prime, is 6x, which if we were to sketch that would be a very steep line like this. But if we were to be given the function, we could figure out that its derivative is y prime equals 2x. So we know that it's not that steep. And not only that, we know that it would pass through this point here, 2, 4. And I think you get the idea, where if we know the equation of the function, we could find the exact sketch of the derivative. So in this case, we know its function, therefore its derivative would be passing through 3/4. I believe that there should be 3/4, sorry, 4/3, negative 4/3. It would be something like this. Obviously not exact, because that's not the point of this video. There we go. So we could find the exact point, or the exact sketch of the derivative. Okay, so we know this because we could figure out where the function passes through given coordinates. Okay. However, if we were tasked to sketch a function given the derivative, we can only sketch a possible curve due to the plus c when we integrate. So these are the exact derivatives from this. However, we know that when we integrate this, we have plus c. So the function, so we know it is a line like this. This is y equals x. But if c were, let's say, -1, it'd be down here. If c were +2, it'd be up here somewhere. So because of the plus c, there is uncertainty as to where the function should be sketched. Likewise with this, we don't know whether it's going to be, if c were, let's say, 0, it'd be something like this. But c could be -1, which would be down here. C could be -10, which would be all the way down here. So I think you understand the issue when it comes to sketching the function from the derivative. This is where slope fields comes into play, that rather than guess a possible sketch of the function, we can sketch a direction or slope field which represents all possible gradients of a curve at any point on the Cartesian plane. So for example, if we were to integrate this, we get x squared plus c. So if we were to guess that c were +2, it would look something like this. And then I would sketch little tangents at points along the curve, like this. Okay, so this is the tangent at x equals -3. This here is the tangent at x equals -2, tangent at -1, tangent at 0, which is horizontal, and so on. If c were -6, you'd move all the way down here and draw tangents once again. And if it were -10, I'd draw tangents once again. But these three are just guesses as to what plus c might be. Rather than guess what c might equal, we instead draw all the possible tangents at all points. So, for example, here at -3 and 11, this tangent here is represented as -3 and 11. Oop, it's off the chart. It should be a tangent like this. And then this tangent, -2, 6, that tangent, which I've drawn, is this one here. So connecting this with the other tangent, which would be drawn something like this, if we were to connect those, would make that sketch of the function. Okay, so I'll demonstrate one more time. -4, 10 would be this tangent, and I'm going to combine that with -3, -3. -3, 3. These two tangents here would be, so this is the first one, and the second one would be this one. So these two, in combination with each other, would make that sketch, would make this sketch. So a slope field here represents all the tangents at all points for all values of plus c for this differential equation. Okay, so this is just a quick introduction as to what a slope field is. It represents all possible sketches of y equals f of x for all possible values of c for a given differential equation. Okay, so I hope that gave you an insight as to what a slope or direction field is. We'll get into the next video on how to actually sketch them, well, how to visualize them when we first begin. Okay, so hope to see you in the next video, and best of luck.